Hello, and welcome to another episode of Physics Chat. Physics Chat is a show where we talk to real life scientists and ask them what it's like to be a modern day physicist. And on today's show, we have the incredible Katherine Shirley, who is a postdoc at the University of Oxford.
You know, if a much younger Dan was here today, he'd be asking you what kind of cheese is the moon made of. 'Cause I used to love watching Wallace and Gromit when I was a little kid.
We do a lecture here actually that talks about how do we know if the moon is not made of cheese.
So the moon is fascinating, but you've also mentioned that you're fascinated by comets as well. So for the uninitiated, what's a comet?
So after coming to Oxford, I've been able to expand from lunar research and onto other bodies in the solar system, including comets. So I'm part of a mission called Comet Interceptor. And comets are these really cool like ice and rock conglomerations that have really extreme elliptical orbits, and they are really known for having these long tails coming off of them, which is really cool because we have evidence of them throughout history. When we have recorded history, even some ancient tapestries from like the 1300s have pictures of comets with these tails on them, and sometimes we can identify those comets if they're regularly returning, so that's always really cool. I think the most well-known comet is probably Halley's Comet, and that returns about every 76-ish years, so your viewers will be able to see that sometime in their life as well.
When is it next planning to come back?
Oh, I was hoping you wouldn't ask me that. I didn't.
Oh, okay. Well, let's put it on the screen.
I think the last one was in the 80s, so if it's 70 years, it'll be.
So 50-ish, so we've got some time.
2050s, something like that.
We've got 30 years to prepare then.
Yeah, brace yourself.
And why the research into comets? What's interesting? What are we trying to understand about them?
Comets are really interesting because they are kind of some of the leftovers from the early solar system formation. And there are two different types. There's short period comets and long period comets. So Halley's Comet at 76 years is actually a short period comet because it comes back into the inner solar system at that rate. There are some long period comets that have millions of years on their orbit, and some of them we think have not even approached the inner solar system. So what we're hoping to find out through some of our missions is that if we can find these types of comets, they will have really well preserved some of that material from the beginning of our solar system, and that can tell us more about what conditions were like and kind of some of the materials that are born when a star system is formed. So we have been able to explore some short period comets. We visited them with several different missions and even landed on one with the Rosetta mission that was landed on Comet 67P, which is really cool. I would encourage you to go check out. They have a really cool video series on YouTube as well about their mission. The mission that I'm working on called Comet Interceptor is an ESA mission, so that's the European Space Agency. And it's hoping to visit a long period comet, so one that we have not studied in depth at all before. This would really help us understand more about what they're actually made out of, because since we haven't seen something from the far outer solar system, so we don't know too much and with exact detail about what those might be made of.
Cool. One thing about the Rosetta mission when that was happening is it made me realize that comets are a lot bigger than I kind of thought, and we were sort of wondering as we were like thinking about this episode, things to ask you. Is it possible for a comet to have like an atmosphere?
Right. So what's really, if you look up the Rosetta mission and you can see some images of the lander on it, you can see how active the surface is.
Yeah.
So comets have atmospheres, but they're transient. So they become thicker, and they're called comas, which becomes that tail as it gets closer to the sun, because you get the heating, so you get more outgassing of material. So it's kind of just like jetting off gas and ice and dust debris. So they don't last super long, but they get thicker as they come to the inner solar system, and then they kind of disappear as they get farther away or they die down a bit.
Okay, cool. Nice, thank you. And what does the future look like for cometology, if that's a word?
Well, hopefully there will be a lot more comet research ongoing, and I hopefully will be involved in that. We're interested in comets to figure out kind of more about what they're made of. And as I mentioned with lunar water, because they contain some of those first ices from the solar system, and we think they might be a delivery system for water to the inner solar system, that would be, really cool if we could figure out more about that water specifically, or that ice specifically, and get a better estimate of whether that is an accurate theory. So with Comet Interceptor, we're hopefully going to find this long period comet, and from that, who knows what will be next. Hopefully we'll be able to actually bring a sample back from it. We have brought samples back from asteroids, which are kind of cousins to comets. They don't have the same type of ice, and they're not as active, but we have been able to go to some of them and actually pull a sample back. So if you have seen information about the OSIRIS-REx mission, it recently landed in September of this year. It brought back a sample, and lots of sample, from an asteroid called Bennu, which is a near-Earth asteroid. And we're able to better study that material. So if we could do the same thing for a comet, which again will be a bit more difficult because they're so active, that poses a lot of hazards to the spacecraft and things like that. So it might be more difficult to actually perform that collection, but hopefully we'll be able to get some sample and really analyze it better in the labs.
Where do these comets come from?
Oh, so there are two main areas. So when we have short period comets, they're generally coming from the Kuiper belt, which is just beyond Neptune. And when we get long period comets, we think they're coming from the Oort cloud, which is kind of at the edges of the solar system. So again, since it's so far away from the sun, that's where we're getting most of this kind of ice material. And that's also, as they're getting farther away, they get the more crazy orbits, and their orbits can be perturbed by other stars that we're passing as well. So effects of more galactal gravity can be more important out there.
Oh, cool. Yeah, the Oort cloud's interesting. Never seen it, but it's out there apparently. Do you think we'll ever see it?
Maybe. I think that, as we're getting better and better technology, we'll probably be able to see stuff. I mean, with JWST, with the James Webb Space Telescope, we are able to see far more of the universe than we anticipated, and it's changing a lot of our ideas about stars, stellar formation, nebula, etc. So I think we'll get there eventually, and we'll be able to prove that our theories are accurate. Hopefully.
I mean, we've sent Voyager 2 and Voyager 1 out. Surely they're going to pass through the Oort cloud at some point in the future.
True.
I don't know when.
I think the issue is that with a spacecraft like that going on one trajectory, if you're trying to look for the Oort cloud, which is massive, things get farther and farther apart. So you have it's less likely that you're going to run into something. I mean, you think of like in the movies, dodging through the asteroid belt and things like that. There's actually a lot of space in the asteroid belt. You wouldn't probably have to worry that much about dodging all those asteroids. So I think similarly, as you get farther and farther away, things are going to be much more spread apart.
So talking about rocks from space, have you ever had the opportunity to hold a rock from space?
Well, I have worked with moon dust. You have to wear gloves at all times, no contamination, things like that. And I will hopefully get some of the Bennu asteroid sample to be able to examine in the lab. So I'm very excited for that. But one of the more common things, more common rocks that you can hold from space are meteorites. So I do have one here to show you. This is a slice of the meteorite Allende. And what's really cool is that these are, self-delivered to Earth. We just have to find them. And they contain some of those original building blocks from the universe because they haven't necessarily been melted up as much to be changed. So when we look at meteorites, that's some of the things that we're looking for. However, because they have come through Earth's atmosphere, they got a bit burnt up on their entry, and then they've been exposed to all of Earth's atmosphere, contaminants, water, etc. It can be difficult to pull apart what is contamination and what isn't. So that's why we really aim to have these sample return missions so that we get pristine sample. And for example, the OSIRIS-REx sample, when it came back, it's been contained under, pristine environment. It's just in a nitrogen environment the whole time, so that none of our water-rich atmosphere is going to contaminate it, and we can understand if there is any water or water molecules within that sample. We can make sure that that's not Earth water. For a comet, again, that poses another problem because they're so much colder. We would have to keep them under really cold conditions as well as a clean atmosphere.
Now it's time for another random question. As you've said, you are a geologist, which is the study of rock and rock formation. So what is the story behind your most favorite rock?
Well, it's really hard to choose a favorite, but I think as somebody on Earth, I have to love fossils in a way. Preserving life, it's really cool, and it's not always just big dinosaur bones that you see. We can actually get preserved soft tissue, like there's some preserved spiders. There's leaves that are old ferns from millions of years ago. That's really cool to see. Even raindrops can be preserved in the fossil record. So I always think those are cool. But also I have a soft spot for volcanic rocks since I'm studying them on the moon as well. And I do have a small piece of basalt that is from a recent eruption on Earth. So I do know exactly when it was created or born. And when you think about how immense the rock record is, I think that's really cool because we try to figure out exactly what the age of a rock is, and our error bars are thousands to millions of years. So if I know exactly when this rock was created, I think that's really cool.
That is very cool. I must admit, when I went to La Palma, which is a volcanic eruption and has recently had a volcanic eruption, we went before that happened. I did pick up a load of rocks and took them back with me. What about you, Fox? Do you have a favorite rock?
When I was in undergraduate, I had a D&D group. One of the people in that group was a geologist, and they had to go on expeditions for their course. And they picked up a couple of rocks and gave it to us as a D&D group. So mine's more of a sentimental connection rather than the rock itself. But yeah, that's my favorite story about rocks.
That's lovely.
Yeah.
And what about you, Dan?
Favorite rock? I think obsidian is really cool. Is that the glassy one? Is that a volcanic?
Yeah.
Yeah.
You'd know. But I think
No, that's true. Obsidian's a really cool rock. Some of the first human tools made out of obsidian. You can make knives with it because it's a glassy rock. It chips very nicely. So yeah, that one's really cool too.
Oh, there you go. You've chosen a cool rock. Thank you so much for being on Physics Chat. It's been so interesting hearing about all the cometary formation, where comets come from, and what we're actually exploring on comets and the planned missions. Let us know in the comments section if you have a favorite rock and the story behind this rock. We would love to hear from you, so please keep writing. But from everyone at Field of View, we hope you have a great day and goodbye. Bye.
Bye.
There's actually a lot of space. You wouldn't have to worry about dodging all those asteroids.
It sounded like you said down in the comet section.
That has been a reoccurring problem for all of Physics Chat.
Unintended this time. It's fine.
Yeah, I'm keeping it.
Yes.